Hey everyone, welcome to my channel. Now, in this session, let's discuss a little bit about test automation architecture. The generic test automation architecture, or gTAA, contains a framework of test strategy. The test coverage starts always as the business demands. In test automation, as the new development comes in, the test automation also comes into picture along with the new development, so that this will help in reducing the time, effort, and increases the frequency in test execution to ensure the stability and integration of the system under test. The test automation coverage can be done usually in three levels: the code level, that is deciding during unit testing, and then the API level to verify the validity and operability of the others operating components and services, that is by making simple data requests and responses to validate connectivity and response times, and at the UI level. This is an important approach to test as a user with the interface. This involves setups and integration among the system and its components. So coming to generic test automation architecture, the few methods used in gTAA are capture and playback, data-driven testing, keyword-driven testing, linear scripting, model-based testing, process-driven scripting, and finally structured scripting. We will look into these in detail in the coming videos, but as of now, let's focus on the structure of test automation architecture. The test automation architecture involves designing, developing, implementing, and maintaining the test automation strategies. The test automation engineer is responsible for all these, like design, develop, implement, and maintain the test automation strategies. In test automation architecture, the key principles are single responsibility, extension, replacement, component segregation, and dependency inversion. The single responsibility is the component must have a single responsibility, and the responsibility must be encapsulated entirely in the component. And when it comes to extension, it should be possible to modify or enrich the behavior of the components without breaking. And when it comes to the principle of replacement, it should be able to be substituted with one test with another test. And in component segregation, substitution and maintenance should be done by eliminating unnecessary dependencies. And the final dependency inversion is components should not depend on specific automated test scenarios. So these are the few principles of test automation architecture. Let's discuss now about generic test automation architecture layers. There are four different layers in test automation architecture. They are test generation layer, test definition layer, test execution layer, and test adaptation layer. In test generation layer, this is the manual design of the test modules. So basically, during test generation layer, there will be a design document where we will come up with the modules that will be used to generate the test scripts. And the next layer is test definition layer. In test definition layer, we take into priority the test conditions, the test cases that were priorly written when doing manual testing or with the requirements, and then the test procedures. So the three different points which we have to remember in test definition layer are test conditions, test cases, and test procedures. And then comes the test execution layer. The test execution layer is when the tests are already written and the test scripts are ready to be executed. Once this execution is done, then we come and we make sure that all the details are logged and reported properly. So the test logging and test reporting comes into this layer. Finally, in the test automation architecture layers, we have the test adaptation layer, where we have the graphical user interface, the APIs, services, protocols, simulators, emulators are all make sure that we are integrated properly with the system under test. So these are the layers in test automation architecture. In each layer, as we see, there are some important work that is done. So in test generation layer, this layer consists of tool support for the following, like manually designing test cases, developing, capturing or deriving test data, then automatically generating test cases from models that define the system under test and its environment. And also the components in this layer are used to edit and navigate test suite structures and relate the test cases to the test objectives or the system under test design document. And we also have the traceability to trace all the specific test cases that are required to automate during test generation layer. Then coming to test definition layer helps in specifying test cases, defining test data, specifying test procedures, defining test scripts, and providing access to test libraries. And in the test execution layer, we have all the tests executed automatically and their results are logged and reported correctly. The test execution capabilities which are set up with the components and the system under test. The test adaptation layer helps in the test support using simulators, emulators, and APIs, protocols, interfaces, etc., like stubs and drivers. The test automation architecture design is the phase in which the test automation engineer needs to analyze the pros and cons of different approaches when designing selected layers of the test automation architecture. The test automation engineer considers for the test generation layer and selection of manual or automated test generation and selection for example requirements, selection of test generation guidelines, selection of test repositories. Considerations for test definition layer: selection of data driven types, keyword driven patterns based on model driven test definitions, and the selection of notation for test definitions include selection of style guidelines, selection of test case repositories. And the consideration of test execution layers include the test execution tool, the selection of interpretation, selection of implementation, selection of helper libraries to ease test execution. And finally, the test adaptation layer involves the selection of test interfaces of the system under test, selection of tools to simulate and observe the test interfaces, and the selection of tools to monitor the system under test during test execution. All this is done during test adaptation layer. These are the important points that we can discuss when it comes to test automation architecture. Hope this has been of some information to all of you. We will discuss more in detail the different approaches for automating test cases. Until then, let's all thrive to learn.